Hello everyone, we are back again with our GRE sessions. Today we are going to discuss about permutations and combinations. Many a times we might have heard about permutations and combinations, but what exactly are those and how are those related with the maths is something which we are going to learn today. In our day-to-day life we all have seen the interest that we all try finding number of ways to do some task. Now number of ways could be very different from what we have done yesterday, and not always we can do it with the same energy, same enthusiasm and everything. Some similar something like goes with permutation also. you know Permutation is something in which you work and you find number of ways to do that work. Okay, you have a task and you find number of ways to do that task. Now even if the four numbers are given, now those four numbers can make how many characters or maybe how many numbers. Okay, so out of those four numbers it is up to you how are you going to place all of those four numbers and how are you going to find the combinations of all of those four numbers. So that is what a permutation and combination is. Now, for this, what all we need we need to have a solution. We need to have a broad mind to find all the possible ways to some work or some task. Now, that can be achieved by using permutation and combinations. What exactly is permutation now? So permutation, uh, you can say that it's something wherein you are making different kind of arrangement, different kind of combinations, and you're just putting them together, okay, to do some task, and that's nothing but the permutation. Now, when it comes to combination is something the way you are selecting those things, okay, that this will work out and this is having a great importance. Okay, so that's nothing but the permutation and combination. Let's not wait for more, and in permutations and combination you might have seen the factorials many a times, and that factorials are going to help you out in this permutation and combination. You might have solved problems related with the probability, and that kind of problems whichever were there in probability, how many number of chances or occurrences would be there for one task, so that would be there. That factorials will help you solve permutation and combination in a really the easiest way. Now let us not wait for more and start with the examples, I believe, because those are something which you'll never ever find out. And permutation and combination, many a times you might find out the ways of solving easier problems. But when the things get difficult, then how would we be solving them? Though they look like the very simplest, but then they are having some techniques to solve. Okay, so let us not wait for more and let us begin. So here is, I believe, the first question which comes up. Now the question is this. Okay, let me just put it as the equation. Now here, let me just put it as the equation, that the question is, if if 15 C, just a moment, 15, it would be going as the C, and the C would be a normal C, and 3R. This 3 are again of. Okay. Now this is something which is equal to. Now this is something which is equal to. Okay. Now you have to find something out. Now what all you need to find is you need to find what is the value of r here. Okay. So let's just find out the value of r. Find r. Let us not wait for more and find out. See, now since it is given in the question that 15 C3R is equal to 15R, C plus R3. Now, if it is given in the question, either 3R is equal to R plus 3 or 3R plus R plus 3 is equal to 15. Okay. These are the number of occurrences and the numbers. Okay. Now let us look ahead. Key what exactly will be there. Now either 3R, here there is a 3R which is equal to R plus 3. And now if we'll be combining all of them, 3R plus R plus 3 is equal to 15 would be the answer. Now here, rather I would write either R would be equal to 3 by 2 or R would be equal to 3 by 2 or R is equal to 3. Now these are the possibilities. Now, see, R cannot be here. Always remember, as in R cannot be a fraction. If at all R cannot be a fraction, then R have to be the number, an integer or the natural number. So I'll just write since R cannot be a fraction, so R is equal to 3. And that's it. That's how we have found it. This is the first question. So, and the answer was R is equal to 3. Now here. Now look at this question which says find the number of ways in which 10 boys can form a ring. 10 boys can form a ring. Now look at this. There is a simple technique which I'm going to tell you. Now, see, 10 boys, 10 different rings. That means every single boy will have one ring. That is B1, B2. If suppose boy 1, boy 2, boy 3, boy 4, if I need to do that. So I'll be writing first ring would be taken by first boy. That is B1. Another ring would be B2. And so on till the 10th. Now, as in, if we'll be assuming that some ring is fixed, here in this case, some ring is fixed, then how many number of ways would be there? So then we have to do the factorial of 9 because there are 10 rings and out of out of that 10, one is already fixed. So we have to find number of ways 9 rings can move. Okay, 9 rings can form. Now let's get ahead and let me just write you. Total number of boys is equal to 10. Now, I'll just tell you number of circular permutations. Circular permutations of 10 different objects. different objects would be equal to bracket. Let me just put it in the equation format and we will just find out. So this will be equal to bracket n minus 1 factorial, and that's it. Now here n minus 1 would be 9. 9 factorial. So how many how to find out 9 factorial? So this will become 9 factorial, sorry, which is now equal to, this will become 362880. Okay, so this is the only way to find out the factorial on the basis of permutation. Okay, so now that's the only thing. Okay, now this is the only answer. That means find the number of ways in which 10 boys can form a ring. So these many number of ways are there wherein boys can form a ring. Okay, so boys can arrange the rings in 9 factorial different ways. Okay, so now let's move. Find the total number of ways 10 beads can be strung into a necklace. Now 10 beads we have to strung into a necklace. Okay, so let me just tell you total number of beads. Total number of beads are 10. Now number of circular permutation of 10 beads. Let me just write here as 10 rings. Okay, now here, look at this one and 10 beads. And here, let me just insert an equation and just to make sure that you'll be understanding this. This would become n minus 1 factorial. This would become n minus 1 factorial by 2. N minus 1 factorial by 2. Of course, 9 factorial by 2, that is nothing but, okay, so here 10 minus 1 would be giving me answer as 9 factorial. 9 factorial by 2. So here 9 factorial, 9 factorial by 2, which is equal to 181440. As in, we are aware that the 9 factorial, which we have just found before some time, so that's the thing. Now let's move a little more ahead. This is the only answer which we have got. So these many number of ways to put 10 beads in a necklace. Let's move. Now here, in a cricket tournament, 5 matches were played. Then in how many ways result can be declared? 5 matches, 2 teams, okay, and okay, now look at this total ways of declaring results. Total ways of declaring results would be equal to, just put this as the equation. 2 to the power n, which is now equal to, which is now equal to 2 to the power 5. Here, why? Because 5 matches are played, and that is nothing but 32 different ways. 32 ways. So let's move a little more ahead. Okay. Now we are done with this question, by the way, that how many total number of ways would be there, and if the cricket tournament would be there, 5 matches are being played. So this would be 32 ways. Okay. Now let's move on to the next question. Now this question says, in a party, every person shakes his hand with every person only once. If the total number of handshake is 210, then find the number of person. So here, let us just put, let the number of persons be x, or let's say be n, not x. Okay, number of person are n. Then total number of handshakes 210, and that too every person is shaking hand only once. Okay, so now let's do one thing. Here I'll just put something like, according to the question, according to the question, this will become NC2. Now this is, of course, this is subscript NC2 will be equal to 210. Now here, let's move a little more ahead and look at this. Now we have to find how many number of people are there actually. Then I'll do one thing, that I'll just put down an equation. This would become the two in fractions. So this would become n into n minus 1 by 2, which is equal to 210, because 210 handshakes are being done. So here this would become 420. 210 into 2 is 420, is equal to n into n minus 1 into n minus 1. Now which is equal to, simply, if at all I'll be solving this one, so this will become 21 into 20. Now this is equal to n. Sorry. This would be equal to n into n plus 1, n minus 1, sorry. This is the equation. Now let us get ahead and see what exactly n means. N would be equal to 21. How does this came? How does this came? 21. What we have done is we have just parted the 21, or maybe 420. We have bifurcated it in 21 and 20. Okay. Now, if at all we are just making because everyone is shaking hands with everybody. So if there will be 21 people, or maybe 21 people would be there, then in that case we have to shake it in 210 times. So that is why. Now here there is something which you need to note down. Okay, here there is something which you need to note down, and I'll just tell you what exactly is that. Now that is nothing but uh, See, along with the handshake, if the person is giving some gift to everybody, then this would become n into n minus 1 only. This would remain n into n minus 1. That is it. That is the only thing which should be there. If along with handshake you are giving gift to somebody, then the formula will remain this enough only. Only this much. N into n minus 1. That's it. Now let's move ahead. And the another question is in a plane, in a plane, there are 16 non-collinear points. So find the total number of straight lines that can be formed using the plane. Okay. Now let me just tell you n is equal to 16. Now n is equal to 16 if they are saying required number of straight lines formed would be equal to NC2. Okay, now NC2 would be there, which is nothing but 16C2. Okay, which is equal to, let me just put the equation, which is equal to now here this would become 16 factorial divided by 2 factorial bracket 16 minus 2 factorial. That's it. Let's find out this one. So this would become 16 multiplied by 15 multiplied by 14 factorial. 14 factorial, which is now here is equal to 2 into 14 factorial again. Now 14 and 14 factorials will get cancelled off. This will remain as 8 into 15. Okay, which is nothing but 120. So there are chances of forming 120 straight line. And that's it. Okay. So these kind of problems are a bit different from what we have studied before, but then these kind of problems will help you understand the way of solving these kind of stuff. Okay. Do not worry, I'll be sharing the formula book as well so that you'll be having your formulas too. Now let's get on to the next example, which is example number 7. Now in a plane, there are 11 points, out of which 5 are collinear. Now find the number of triangles made by these points. Now here, let me just put n is equal to 11. M is equal to 5. N is equal to 11, M is equal to 5. Now here, required number of triangles would be equal to NC3 minus MC3. Oh, sorry. MC3, which is now equal to 11C3 minus, sorry, minus 5C3. Now, let us just put on the equations to understand it in the more better manner. So now, let me just put on the fraction. So here it is, 11 into, sorry, 11 into 10 into 9 divided by 3 into 2 into 1 minus, now here 5, 4, 3 by 3, 2, 1. Okay, now which would be equal to 165 minus 10, which is equal to 155. And that's it. Okay, there are 155 number of triangles made by 11 points, and which are out of which 5 are collinear. Okay, so 155 triangles can be made. Now, these problems, as in I was telling you since the very beginning of the session, that these are very different from what we have studied before, but this may help you in solving many questions which may come up in your way. Now, this is nothing but time to give you the practice work, and that's it. I'll be sharing the sheet with you people. So, thank you so very much, and that's it for the day.